Same directions here again as our last two problems. We want to describe the transformations, graph, and then identify our domain and range. Taking a look at this equation, we have c of x is equal to 2 times the cube root of x minus 2 minus 1. In order for us to graph and use transformations and write those down, we want to know what the parent function looks like. This is a cube root. So the parent function would be y is equal to the cube root of x. If you made an xy table and plugged in some values that gave you nice integers, we would have probably these 5 points. Our graph goes through those 5 points, and this is what it looks like. This top part here kind of looks like the square root graph, but because it has an odd index, we can plug in negative x values, so we do have the other half of it, whereas the square root graph only has this top part. So those are the points that we're going to focus on as far as our parent function goes. If we compare the parent function equation with this equation, I see that there is a 2 in the front. And here, there's an invisible 1. That means that this graph is going to be twice as steep. We would say that it has a vertical stretch by 2, or you could think of that as being 2 times as steep. And then the other things that are different between our equation here and our parent function is we do have subtraction in a couple of places. Subtraction inside the radical is going to be horizontal shift, and if it's subtraction, that will go to the right. And if you have addition or subtraction outside the radical, that's going to cause your graph to go up or down. That's your vertical shift, and subtraction is down. So I'm going to go through and first of all describe the transformations. Did that with those phrases. Now I'm going to graph. I'm going to take this parent function graph, and to start with, I'm going to make it twice as steep. And then after I do that step, I'll take that graph and I will go right 2 and down 1. So let me make a quick sketch of our parent function graph again here. And to start with on this one, I am not even going to put stuff on the x and the y axis. I'm just going to draw the shape in, and I'll put those points in. So the 3 points that our parent function graph went through, if we were graphing y equals the cube root of x, they would go through the point 0, 0, the point 1, 0, sorry, the point 1, 1, and then the point 2, 8. And then coming back the other direction, it would go through the point -1, -1, and out here at -8, -2, we would have another point. So that's what the parent function graph looks like. And now what I want to do with these is I want to go through and make them twice as steep. So in my next graph here, I'm going to make this graph be the same as the one up above, but I want to make it twice as steep. So what would the graph of y is equal to 2 times the cube root of x look like? What would a graph be that is twice as steep as this one? Well, let me start with this point out here. This point is 2 units above the x-axis. We want to make it twice as steep, so we're going to multiply that by 2. And if we multiply that height of 2 by 2, that would be up at a height of 4. So at 8, 4, we're going to have one of our points. We have a point here at 1, 1. It's at a height of 1, and if I double that, that would be at 1, 2. So another point that is on our graph is the point 1, 2. 0, 0 is at a height of 0, and if we double that, it's still 0. So it's going to go through the origin again, still going to go through 0, 0. -1, -1. That's 1 unit below. If I double that, that would be 2 units below. So that would be the point -1, -2. And then we have this point here, -8, -2. That's 2 units below, and if I double that, that would be at -4. So at -8, -4, we would have another point. And then I want it to have kind of that cube root shape to it. So it starts out pretty steep, and then the further you go to the right or to the left, it would begin to be less steep. Again, this graph is going to continue to go to the right and up, right and up, right and up. It's never going to level out. It'll keep going upward as we go to the right, and as we go to the left, it'll continue to go downward. All right, that's one of our transformations. We have 2 more. We can do these 2 in the same step. We can take our graph and we can slide it right 2 and down 1. So to finish the graphing part of this, I want to take the graph that we had in our last step, and I want to do our graph, which is, let me put it down here, y is equal to our original, which is 2 times the cube root of x minus 2 minus 1. This is our final graph. I just need to take the graph we just did in orange, and I'm going to move that right 2 and down 1. All right, so let's take this point right here, the point 0.84, and I'm going to go right 2 and then down 1. So that would end up being the point 10, 3. Another point on our orange graph is the point 1, 2. That would be here. I want to go right 2 and then down 1. So that would be the point 3, 1. Our origin, we want to go right 2, down 1. So that is the point 2, -1. We have another point here at -1, -2. I want to go right 2 and down 1. So that would be the point 1, -3. And then finally -8, -4. If I go to the right 2 and then down 1, that would put me at the point -6, -5. Should probably make one more mark here. So -5 is on there. And then we can draw in our shape. So with a couple of transformations, we can come up with our graph. This graph is twice as steep as the parent function, and it's also been moved to the right 2 and down 1. The last thing that we need to do is take a look at this graph and come up with our domain and our range. Domain and range for cube root functions is pretty easy. This graph goes forever to the right and forever to the left, so our domain is all real numbers. You could use the all real number symbol. You could use set builder notation. Like that. Or you could use interval notation like that. So use the all real number symbol. If you're going to use set builder notation, it's the set of all numbers x such that x is an element of the real number. This symbol is read is an element of, it looks like a capital C with a little line in the middle. Otherwise, interval notation would be from negative infinity to infinity. When you look at the range, this graph does go up for forever, very slowly, and also down for forever. So the range is actually the exact same thing. It would be all real numbers. You could also write your range using set builder notation. We would have y's in there instead of x's, but it would look the same. Or you could use your interval notation with the parentheses and the brackets. In this case, parentheses at either end because we're working with negative infinity to infinity.